Hello, I'm Rajendra Bade, and in this video you will learn sections of solids, pyramids. This problem. A pentagonal pyramid, base edge is 30 millimeters long and height 50 millimeter, is resting on HP with its axis vertical. One of its base edges is perpendicular to VP and on the left hand side. In this position, it is cut by a cutting plane perpendicular to the VP and inclined to the HP by 30 degrees. The cutting plane bisects the axis of the pyramid. Draw sectional front view, sectional side view, sectional top view and true shape of the section. Now listen, in sections of solids, two very important steps, position of object and position of cutting plane. Let's check here what is position of this object. A pentagonal pyramid, base edge is 30 mm long and height 50 mm. This is information about size of the object and shape, which is pentagonal pyramid. It is resting on HP with its axis vertical. This is important information. Remember now, listen to me very carefully. If axis of a solid is perpendicular to HP, in other words, vertical, then true shape of base appears in top view. If axis is perpendicular to VP, in that case, true shape of base appears in front view. Now, in this case, axis is vertical, therefore, true shape of base in top view. We should start a drawing from true shape of base. In this case, it is pentagon and it is in HP. So let's start. Draw XY line, label XY line. Labeling is very important. Since we use first angle method of prediction, HP must be below XY line and VP must be above XY line. So now, since axis is vertical, we know true shape of base in HP. So we are going to draw regular pentagon of sides 30 millimeters in top view. But orientation of pentagon. Take care of all details about position while drawing true shape of base. One of its base edges is perpendicular to VP. Remember, top view gives details with respect to VP. So one of its base edges must be perpendicular to VP in the top view. That is perpendicular to XY line. We are going to draw one edge. Also, that perpendicular edge is on the left hand side. So take care of this while drawing true shape of base. So here is the base edge, which is perpendicular to VP. Now complete pentagon as usual. So measure 108 degrees with that edge very carefully and complete the pentagon. And this is how we have completed the pentagon. Now label all base corners. Labeling is very important. Unless you label the corners, you should not proceed. Labeling helps you to complete the drawing quickly and without any mistake. And if at all there is a mistake, you will be able to rectify that mistake very quickly. Now here it is true shape of base. But it is pyramid, it has apex. Since axis is vertical, in the top view, apex coincides with the center of base. And that is why we should mark apex. To mark apex, that is center of pentagon in the top view, join any two corners with midpoint of corresponding opposite edges. Now here we have located point O, that is apex, in top view. Now join apex with all base corners. But when you draw views of the object in given position, don't make any single edge dark. Remember, in sections of solids, don't make any single edge dark unless you cut the object. Remember this. Now we'll start drawing front view. Project all these base corners in front view. So A dash, B dash, C dash. Watch here, B dash and E dash are on single projector. They coincide in the front view. C dash and D dash coincide in the front view. All 5 base corners are on XY line. That means entire base is in HP. Now let's locate apex in the front view. So this is projector for apex. Now check whether we know height of the object. Height doesn't appear in the top view. In front view, we are going to measure height of the object, which is given 50 millimeters. So measure 50 millimeters. And this is how we have labeled O dash. Remember, 50 millimeter is to be measured vertically because it is height of the object. Now join apex with all base corners. Here it is axis. From apex perpendicular to base, the line is axis. O dash A dash is face edge. Similarly, O dash B dash. Watch here, O dash B dash and O dash E dash coincide. O dash C dash and O dash D dash coincide. So along this line, even if it is a single line, there are 2 edges, and the 2 edges are OC and OD. So because we have labeled it properly, there will be no confusion at all. Also along this line, there are 2 edges, OB and OE. So this is how we have completed front view and top view of the object in given position. But once again, I am telling you, don't make a single edge dark unless you have cut the object. Now check whether side view is asked. Remember, if side view is not asked or if side view is not required, don't draw side view. In this problem, you are asked to draw side view. So we'll draw side view as usual. So draw a line 45 degrees at a convenient distance, and as usual project all corners in the side view. So these are horizontal lines up to the 45 degrees line, and then project all these points on XY line. And this is how we have transferred all base corners on HP. Now look at apex in the side view. Label it as O double dash. And of course, you should join apex with all base corners. So these are all 5 face edges, OA, OB, OC, OD and OE in the side view. Now, position of object is over. This is very important, very first step, to draw views of object in given position. Now, we should locate cutting plane. That is the second important step. Check what information we have about cutting plane. In this position, it is cut by a cutting plane perpendicular to the VP and inclined to the HP by 30 degrees. The cutting plane bisects the axis of the pyramid. Okay, now listen one, it's very important. If cutting plane is perpendicular to HP, that is, if cutting plane is vertical, then it appears a line in the top view. If cutting plane is perpendicular to VP, then it appears line in the front view. In this case, cutting plane is perpendicular to the VP. So it is a line in the front view. Now, cutting plane is inclined to HP by 30 degrees. So this cutting line in the front view, we should draw at an angle 30 degrees. But we can draw infinite lines at an angle 30 degrees in the front view. Then where exactly the line is? The cutting plane bisects the axis. So we should draw cutting line through midpoint of the axis. Now here I have drawn a line. I have seen many students getting confused about orientation of the cutting line. Whether we should measure 30 degrees in this manner or in this manner. Now listen. Sectional views are special purpose views to watch the internal details of the object. So when we cut an object, the portion nearer to observer is always imagined removed. So portion nearer to observer is removed portion, and portion nearer to XY line is a retained portion. Now let's assume we have cut object in this orientation, and this is the retained portion. Now observer is watching from top, let's assume. Now in the top view, section, remember section is newly generated surface because of the cutting. So section is visible from top. Now it is left side view. Observer is watching from left, imagine. And now you will find that from left side this section is hidden. And that means this cutting line orientation is not correct. Now, suppose we draw cutting line in this manner. Portion nearer to observer is removed portion. Portion nearer to XY line is retained portion. Now watch carefully. From top, section is visible, and also from left side, section is visible. So section is visible in the top view and section is also visible in the side view. So this is correct orientation of the cutting line. Of course, if side view is not asked, then you may draw cutting line in this orientation also. Okay. Now, but in this problem, this is the correct orientation of the cutting plane. Now we'll draw cutting plane in proper order, in correct position. Okay, so this is position of the object, the given position of object, and the pyramid is cut by a cutting plane perpendicular to VP. Cutting line is in the front view, inclined to HP by 30 degrees. Cutting line is at an angle 30 degrees, and the cutting plane bisects the axis of the pyramid. So cutting plane must pass through midpoint of the axis. Now axis is 50 millimeter long. So locate midpoint of the axis, and through midpoint draw a line at an angle 30 degrees with the horizontal. So this is how we have located the cutting plane. So two very important steps are over: position of the solid and position of the cutting plane. Once you have completed cutting plane line, remaining procedure in all the problem is very straightforward. What is that procedure? Listen. Always label points of intersection of cutting plane line and edges of the object. Simple. Label points of intersection of cutting plane line and edges of the object. Watch here. Here, cutting plane line is intersecting edge OE. Label this point with letter P. So PE. Front view, it is front view. That is why there is dash here. This is point PA in front view. P later is for the point which is lying on the cutting plane, and also this point lies on edge OA. Therefore A dash. PA dash, it is a point on cutting plane and line OE. Now let's label this point. It is PB and PE. Watch here, there are two edges, OB and OE coinciding here. So cutting line intersects both these edges. That is why I have labeled this point as PB and PE. Point PB is on edge OB, and point PE is also it's on edge OE. But PB and PE are coinciding here. Now let's label this point also. Here cutting plane is intersecting edge OC and edge OD. So these are points of intersection of edges and cutting plane. So label points of intersection of cutting plane line and edges with extra letter P. Now when cutting line intersects an edge, it creates a corner of the section. Remember, section is the newly generated surface because of the cutting. When we cut a solid object, it creates a fresh surface, that is section. Now this section has 5 corners. That means this newly generated surface, because of cutting, nothing but the section is a pentagon. Not necessarily regular pentagon, but it is a polygon with 5 corners. These are 5 corners we should transfer on the respective edges in the top view and in the side view. Okay, so let's do that. From PA vertical projector. So this is how PA dash we have transferred in the top view as PA on edge OA. Take care. When we draw this vertical projector, it intersects edge AB also. But remember, not all points of intersection in the diagram are significant. This projector is projector of PA. So on this projector, point PA is, and point PA is also on edge OA, and that is why we have located PA on edge OA in the top view. Now we'll transfer PB and PE. So this is projector from PB. So we got PB on edge OB. Proceed, and we'll get PE on edge OE. Now let's transfer PC and PD. So here it is that projector. PC is on edge OC and PD is on edge OD. Remember, when you draw this vertical line, it intersects base edge also. But that point of intersection here, this point of intersection has no significance at all. So this is how all 5 base corners are in the top view. Now let's transfer all these 5 base corners in the side view. So draw projectors and on respective edges transfer the points. So PA is on edge OA, PB and PE on edge OB and OE, PC and PD on edge OC and on edge OD. So this is how all 5 base corners or corners of the section are in the top view and also in the side view. Unless you transfer all corners of the section in a view, don't join the corners of the section. And we have done that. So let's continue. Join all these corners, that is all these P points, to form a polygon. This is that section. It is surface. It is newly generated surface. So it has closed boundary, remember. Similarly, we'll join these points to form a closed polygon in the side view. So here it is section in the side view. So we have completed section in all the 3 views. This is section in the side view. Here it is section in the top view. And here section is a single line in the front view. Now, we should make retained portion dark. Have you noticed? Portion nearer to XY line I have made dark. Portion nearer to observer is imagined removed. Don't erase that portion. Only thing is, you should not make removed portion dark. Make only retained portion dark. Excuse me. Now let's proceed. The view in which cutting line is, that view gives you clear idea about removed side and retained side. So refer this figure, the figure in which cutting line is, to make retained portion dark in other 2 views. Portion nearer to apex is removed portion. Entire base is retained, matlab all base edges are retained. So AB, BC, CD, DE, these are all retained edges. So make base edges dark. And face edges, PA to A is retained, PB to B is retained, and accordingly we are making these edges dark. So this is how sectional top view is complete. Now retained portion in sectional side view. Again, all base edges are retained. So I made all base edges dark, and face edges, Below the section, that is PE to P, PD to D are dark. Now sectional views are special purpose views. Hidden details are not necessary in sectional views. And one more thing, inside the section, there should not be any edge, any single edge. Hidden edge or visible edge will not appear inside the section. Now section, that is newly generated surface, we should draw hatching lines. Hatching lines are thin lines nearly 45 degrees inclined parallel to each other. So let's draw hatching lines in these two views. So this is how I have shown section using hatching lines. Now we are also interested in true shape of the section. How to draw true shape of the section? Try to understand. Simple logic we use here. If a surface is parallel to HP, then it shows true shape in the top view. If a surface is parallel to VP, then it shows true shape in the front view. Using this simple basic logic, we are going to draw true shape. Now here is the cutting plane line. Section is on this line, which I have colored here. So make this line, that is cutting plane line, parallel to XY line. So cutting plane line is parallel to XY line, means the section is parallel to HP. So in top view, now you will get true shape of the section. But before that, all these corners of the section, that is all these P points, we should transfer on this horizontal cutting line. Use compass and transfer the distances. PB to PC, I have highlighted this distance with red color. This distance to be transferred here. Similarly, distance PA to PB, here I have highlighted that with blue color, that is to be transferred here. So this is how we should transfer all corners of the section in or along this horizontal cutting line. Now project these points in the top view. So here it is PA, horizontal line through PA and vertical line through PA dash, and you will get PA, that is corner of the true shape of the section. Remember, here we are transferring only corners of the section. So the points which I have labeled with red color, these are corners of the section. Only these points are to be transferred here. Don't draw projectors from corners of the base. So here it is PV. And this is how transfer all the corners for true shape. Join these corners to form a closed polygon. And this is true shape of the section. So this is final drawing. In your completed drawing, all dimensions which are given in the problem must be included. So length of base edges, height, cutting plane through midpoint. So this dimension is 25. It's given in the problem that cutting plane bisects the axis and cutting plane is inclined at an angle 30 degrees. So all this information, that is all dimensions given in the problem, you should insert in your drawing. Be sure that you have labeled XY line. Be sure you have labeled HP VP. Now let's consider this problem. Read problem very carefully. A pentagonal pyramid has length of base edges 35 mm and height 70 mm. It is resting on HP with its axis vertical and one of the base edges is parallel to and away from VP. Let's focus on this information, that is position of object. So take care of size, shape of object and position of object and start drawing. Remember, you should start drawing with true shape of base. Now check where true shape of base is. Axis given vertical. When axis is vertical or perpendicular to HP, then true shape of base appears in the top view. So once again I am telling you, If axis is perpendicular to HP, that is when axis is vertical, true shape of base appears in top view. And when axis is perpendicular to VP, true shape of base appears in front view. So here true shape of base is in the top view. Next, one of the base edges is parallel to and away from VP. So one of the edge of that true shape of base we are going to draw parallel to XY line and away from XY line. Take care of all these details while drawing true shape of base. So let's start. Here it is XY line, label XY line, label HP VP, and this is that edge, 35 millimeter long edge. Remember, don't draw single edge dark at this stage. You should make edges dark only after you have cut the object. So right now, draw all the three views very faint. Let's continue. Now we have drawn one of the edges. Take help of this edge to complete the regular pentagon. So measure 108 degrees very carefully and complete the pentagon. This is true shape of base. Check one of the base edges is parallel to VP and away from VP. Now level all corners of the base. Now locate center of the base. Join any two corners with corresponding edges midpoint. So this is how we have located center of pentagon and therefore apex. Now join this apex with all base corners and those will be face edges. So OA, OB, OC, OD and OE, these are all face edges. So we have completed true shape of base, or you can say top view of the object with all edges are in corresponding position. Remember, don't forget to draw any single edge dark. Otherwise, you will face lots of difficulties while completing the drawing. Don't forget to label all corners. Now let's project all these points in the front view. So this is how we have transferred all base corners on XY line. Label all these points. So A dash, E dash, B dash, D dash and C dash. Now let's look at apex in the front view. Height is given 70 millimeter. So measure 70 millimeters vertically and locate apex. So here it is O dash. Now join O dash with all base corners. O dash A dash, O dash E dash, O dash B dash, O dash D dash and O dash C dash. Now in front view, edge OB is away from observer. Edge OB is hidden. So draw edge OB hidden. Don't make any single edge dark at this stage. Now let's complete side view as usual. So this is line exactly at 45 degrees with XY line and draw projectors to transfer all these corners in the side view. Label all the points. Join apex with all base corners. Vertical line from apex, that is axis. Now let's look at cutting plane. Listen once again. If cutting plane is perpendicular to HP, that is if cutting plane is vertical, then it appears a line in the top view. If cutting plane is perpendicular to VP, then it appears line in the front view. Now first thing is whether cutting plane is perpendicular to HP or perpendicular to the VP. So we have here clear information. Cutting plane is perpendicular to VP. So we should draw cutting line in front view. Cutting line is inclined to HP by 60 degrees. So we'll draw that cutting line at an angle 60 degrees. The cutting plane bisects the axis. So locate midpoint of the axis. So axis is here along line OB. In the front view, axis is along line OB. So get midpoint of the axis. So measure 35 millimeters, that is half of the axis length. So here it is midpoint of the axis, and through this point draw cutting plane line. at an angle 60 degrees with horizontal. So this is cutting plane line. Remember, here you should not draw cutting plane line in this orientation. The cutting plane line I have drawn is the correct orientation at an angle 60 degrees bisecting the axis. Once you have located the cutting plane line, remaining procedure is very straightforward. Label points of intersection of cutting line and edges of the object. So here it is PA, PE, PV, PD. So these are PA is point of intersection of cutting line and edge OE. PE is point of intersection of the cutting line and edge OE. And this is how we have labeled these points. But something new in this problem. Watch, here cutting line is intersecting base. Remember, when cutting line intersects base, it intersects two edges of the base always. Now watch here, line CD or base edge CD, where is this edge in front view? So C dash D dash. Have you noticed cutting plane line is intersecting edge CD? Now focus on edge BC. Where is this edge BC in the front view? So B dash C dash. Check, cutting plane line is intersecting edge BC also. So here there are 2 points. Remember, when cutting plane cuts base, it always gives 2 points. It always cuts 2 base edges. So label those points U and V. So I have labeled this point with letter U as well as with letter V. Now it is better to have standardization in labeling also. So now henceforth, when cutting plane intersects base, we will label that point as U as well as V. Remember, U and V, these 2 points will be always on the base edges, and points on the face edges will label with extra letter P. So all these P points are on face edges and U, V points are on base edges. Now let's transfer all these points in the top view. PA. As usual, draw projector. Watch here, PA is on edge OA, PE is on edge OE, PD is on edge OD. Now let's transfer U and V. So projector from U. Check. Point U is on edge BC and point V is on edge CD. Remember, when you draw projector from point UV in the front view, this vertical projector intersects edge OC also, but that point has no significance at all. We are sure that this is projector for U and V, and U and V are on base edges. So point U we have marked on base edge BC and point V we have marked on base edge CD. I have not yet transferred point PB. Now try to understand. When an edge appears vertical in a view, for example here OB, so this edge OB appears vertical in the front view, then you will not able to transfer these points in the top view. They say PB, if you project it in the top view, you don't get sharp intersection on edge OB. So there is a special procedure you will have to follow. From PB, draw a horizontal line on edge OA, that is on boundary edge. So temporarily we have transferred PB on edge OA. Now transfer that point on edge OA in the top view. And then draw an arc. Center of this arc is O. And bring that point again to respective edge in the top view. So PB is on edge OB. This is how we transfer PB. Now let's transfer all these points in the side view also. If you draw projector from points U and V, from front view to side view, you don't get any sharp intersection on the base. So you cannot project U and V using front view. So we'll transfer U and V in the side view using top view. We already have U and V, these 2 points in the top view. So this is how we have transferred U double dash, and V double dash. So we have transferred points U and points V from front view to top view to side view. Now remaining all points, that is all these P points, we can easily transfer in the side view. PA, PB, PC, PV, etc. Now listen, when a cutting line intersects an edge of object, it creates a corner of the section. So this section has 6 corners: PA, PE, PB, PD, U and V. That means in this case, even if we have cut a pentagonal pyramid, the section is hexagon. Of course, not regular hexagon, but it is a polygon with 6 corners. Now join these corners to form closed polygon. So here it is section in the top view. And here it is section in the side view. Remember, section is a surface. It is a newly generated surface due to the cutting. Therefore, a section has closed boundary. Don't forget this. A section has closed boundary and no other visible edge inside the section or a hidden edge inside the section. The section to be hashed, but we'll do it later. First, we'll make now remaining portion dark. Portion nearer to XY line is retained portion, so we should make it dark. The view in which cutting line is, that view gives you clear idea about removed portion and retained portion. Observer is watching from top for sectional top view and observer is watching from left for sectional side view. So portion which is nearer to observer is a removed portion. Portion which is closer to XY line is retained portion. Now take help of this diagram of this view and identify retained portion in the top view. Now check here. Points UV. Left portion, left side of UV is removed. So left side of the section is removed. So this portion is removed. Don't make it dark. Right side portion of UV is retained. So right side portion of the section you should make dark. So let's do that. So this is how I have made retained base edges dark and then all face edges dark. Remember, inside the section there should not be any visible edge or hidden edge. Again here, check here, apex portion, that is above the section portion, is a removed portion. So check boundary of the section here, upper boundary of the section, and above that portion is removed portion, and below the portion it is retained portion. So make retained portion dark in the side view. So sectional front view, sectional top view, sectional side view are complete. Only thing is now we'll have to hatch it. One more thing I want to tell you. PB. Do you remember how we transferred PB? PB point, take on boundary edge by horizontal line, project it in the top view on edge OA, and then take it back to its original edge. If you have side view, then you can transfer PB from side view also. This is a front view of PB. Project in the side view, and from side view you can draw projector in this manner to get PB in the top view. But not always we draw side view. That is why you must know the procedure of drawing PB or transferring PB in the top view from front view. So PB dash, take it on edge OA, project it on edge OA, and then O as a center, draw an arc to transfer that PB on its own edge. So hatching is done. Now to draw true shape of the section. Same procedure what we studied in the last problem. Draw the cutting line. It is in the front view. Cutting line is in the front view. That is above XY line. So draw the cutting line above XY line, parallel to XY line, and transfer all the points, P points and UV, that is corners of the section, on this horizontal cutting line. Use compass to transfer these distances from original front view to the horizontal cutting line. And then by drawing projectors from all these points. And from remember, we are drawing true shape of base. So only corners of the section. Sorry, we are drawing true shape of the section. So only corners of the section are to be transferred here. And this is how we'll get all the 6 corners of the section in or for the true shape. Join these points to form a closed polygon and draw hatches. So this is the final drawing. Now let's read this problem. A hexagonal pyramid, base edge is 25 mm and axis 45 mm, is resting on HP with its axis vertical and two of its faces perpendicular to the VP. So this information in red color, that is information about shape of the object and size of the solid. It is cut by a vertical plane that makes angle 45 degrees with the VP. The cutting plane is 10 mm away from the axis of the solid. Draw sectional front view, sectional top view, sectional side view and true shape of the section. First important step, position of object. Now it is hexagonal pyramid. Base edge is 25 and axis 45. We should start with true shape of base. Take first decision where true shape of base is, in HP or in VP. So its axis is vertical. Once again I am repeating, if axis is perpendicular to HP, that is vertical, then true shape of base appears in top view. When axis is perpendicular to VP, then true shape of base appears in front view. So here we are going to draw true shape of base in HP, that is in the top view. About orientation, two of its faces perpendicular to the VP. So draw hexagon with two base edges vertical, that is perpendicular to XY line. So let's continue. So here true shape of base. Check here, two edges are vertical. So draw hexagon in this manner, and like earlier two problems, complete front view. Apex is 45 mm because that is height of the object given. 45 mm is height of the object. And by drawing projectors, complete side view also. Don't make any single line dark. Unless you cut object, you should not make any single line dark. Now, how to draw hexagon? Some of the students, they have this difficulty. That is why I am explaining you. First, locate center line. So draw center lines. Then take length of base edges as a radius, that is 25 mm, and complete the circle. It should be very faint circle. Now same radius in compass and from ends of vertical diameter. Now listen, this is very important. If you want hexagon with two of its edges vertical, then consider ends of vertical diameter. When you want two edges of hexagon vertical, then use ends of vertical diameter. And from these ends of vertical diameter, you cut the circle. Take radius of the circle in compass and cut the circle on both the sides. Check what I mean. So cut on this side and also cut on this side. Now from lower cut on both the sides of the axis. Now join these points to form the regular hexagon. So this is how you are going to draw hexagon here. Apex, of course, center of the circle. Now join apex with all base corners. These are all face edges. And this is how first stage is over. Now, is it correct position? Check here. This face, in problem, it is mentioned that two of its faces, pyramids have triangular faces. It is hexagonal pyramid, so it has 6 triangular faces. So out of these 6 faces, 2 of its faces are perpendicular to the VP. So watch this face AOF. This triangular face, and also focus on this triangular face. These two triangular faces are perpendicular to VP. Remember, if a surface is perpendicular to VP, then it should appear a line in the front view. Now, where is that edge surface OAF in the front view? So O dash, A dash, F dash. Watch here. It is a single line. So that means these two faces appear a line in the front view. And therefore, these two faces are perpendicular to VP. Now listen to a statement I am making here, and remember, if a surface has an edge perpendicular to VP, then it means the entire surface is perpendicular to VP. 1 second, listen. If a surface has an edge perpendicular to VP, then entire surface is perpendicular to VP, and that is why we started with two of its base edges vertical. So correct position. This is first step. Now second step of the problem is locating cutting plane correctly. Let's check it. It is cut by a vertical plane that makes an angle 45 degrees with the VP. The cutting plane is 10 millimeters away from the axis of the solid. Okay. It is cut by a vertical plane. Do you remember in earlier two problems what I told you? If a cutting plane is perpendicular to VP, it appears a line in front view. And if a cutting plane is perpendicular to HP, then it appears line in the top view. Now in this case, the cutting plane is vertical plane. That is a plane perpendicular to HP. So in this case, cutting plane line must be in the top view. So we are going to draw cutting plane line in the top view. It makes 45 degrees with VP. So top view gives details with respect to VP. So cutting plane line should be at an angle 45 degrees. And it is 10 millimeters away from the axis. Now try to understand. In the top view, apex is this point and axis is also this point. Because axis is vertical, it appears a point in the top view. So check where is the axis in the top view. So point O is axis in the top view. Now from point O at distance 10 millimeters, the cutting plane line is. Draw a circle of radius 10 millimeters. This is circle of radius 10 millimeter. Now logic is any line which is tangent to the circle will be at distance 10 millimeter from the center of the circle. So now one tangent we are going to draw. Tangent to the circle, and it should be at an angle 45 degrees. Cutting plane is at an angle 45 degrees. Now one more important thing. Be sure before you draw cutting plane line, be sure about its orientation also. Try to understand what I mean. Suppose we locate cutting plane in this manner. This line is 45 degrees and it is 10 millimeters away from axis. So this cutting line satisfies all this requirement. But check here. Portion nearer to observer is retained portion. So this is retained portion. From front, section is visible, but from left side section is hidden, so you will not get section visible in the side view. So this is not the correct cutting line. Now if we draw cutting line in this manner, then this is also wrong for the same reason, because from left side section is not visible. Okay, in this case this is retained portion, but and smaller portion is retained and larger portion is removed. So therefore this is also not the correct cutting plane line. Now check this cutting plane line. Portion nearer to observer is removed portion and this is a retained portion. Section is visible from all the two, that is from side and from the front also. So this is the correct position of the cutting plane line. We have selected cutting plane line in such a way that section is visible in the front view, also in the side view. Not only that, we have selected cutting plane line so that smaller portion of the object gets removed. Larger portion of the object retains. So this and only this is the correct position of the cutting plane line. Excuse me. Now, how to draw line exactly at 45 degrees and touching the circle? Try to understand. In this diagram, we already have a line at an angle 45 degrees. This line we have drawn for side view. Set roller with that line. Roll it to draw a line tangent to the circle. So this is how we have drawn a cutting line which is 10 millimeter away from axis. Is like chain line, longer dash, shorter dash, end dash is dark. Once you have located the cutting plane line, remember what I told you? Position of the object and position of the cutting plane. These are two very important steps. Once you have located a cutting plane line, remaining procedure is same in all the problems. Try to understand. Now label points of intersection of cutting plane and edges of the object. So PD and PE, these 2 points are on face edges. That is why we have used extra letter P here. And cutting plane also intersects this hexagon, matlab edges of hexagon. So it's U and it's V. Point U is on edge CD. Point V on edge EF. Remember, the point of intersection on face edges you label with letter P. And points of intersection of base edges and cutting line you should label with letter U and V. And also remember, when cutting plane intersects base, it always intersects 2 base edges. Okay, so the section has 4 corners. So it is a polygon with 4 corners. Not necessarily exact square or rectangle or rhombus, but it is a polygon with 4 corners. Let's transfer these points in the side view and in the front view. U point. It is on CD. CD is a point here. So यहाँ U dash. V point on the base. PD on edge OD. Watch here. PD on edge OD. And PE. If you draw projector, PE is on edge OE. But you don't get any sharp intersection on edge OE. This is what we discussed in the last problem also. If a point is on an edge that appears vertical in front view or in top view, then to transfer that point, we'll have to use a proper procedure. Try to understand the procedure, which is very much similar to the procedure we used in the last problem. Have you realized? PE using an arc center point O, we transferred on edge OF. Now project it on edge OF and then bring back to original edge OE by drawing a horizontal line. This procedure is exactly opposite to the procedure we used in the last problem, because in the last problem we transferred the point from front view to top view. In this problem we are transferring the point from top view to front view. So this is how we got PE. So all 4 points are there in the front view. Now let's transfer all these points in the side view. So PD, PE and U and V you should transfer from top view to side view. So check, all 4 corners are there in the side view also. Now in front view and in side view, since we have got all corners of the section, we'll join these corners to form closed polygon. So this is section in front view. Here it is section in top view. Now make retained portion dark. Remember, the view in which cutting plane line, that view gives you clear idea about removed portion and retained portion. Portion nearer to observer is removed portion, make retained portion dark. All face edges or portion of face edges on the retained portion we have made dark. Now take help of this view to make other views dark. Check here. Section. Remember in front view this is left side and this is right side. Left side and right side. So left side with reference to this cutting plane. Left side is removed, right side is retained. So make here right side of the section dark. Side view. You need not check each and every edge. Try to understand. This is cutting line. In the side view, this side is actually front of the object. When observer watches in this direction, it is having front view of the object, remember. When observer is watching in this direction, it is observer is having top view of the object. So this is front side, this is back side. This is top side, this is bottom side. Now check here. With reference to this, back side is retained. This is front side and back side. So back side, that is this side. Or you can use this logic. Apex portion is retained portion. So make this apex portion dark. Let's do that. This portion EV. Check here EV portion. EV portion. It is on the removed side. Check front side is removed. So this side is removed side. Don't make it dark. So this is how we have completed sectional top view, sectional front view, sectional side view. Now let's draw true shape of the section. Watch here, cutting plane line is in the top view. Make it parallel to XY line in the top view, that is below XY line, and now you will get true shape in the front view. Remember, if a surface is a parallel to VP, then it gives a true shape in front view. If a surface is parallel to HP, then it gives true shape in the top view. Now this cutting line is top view. So top view gives the details with respect to VP. So top view parallel means that this surface is parallel to VP. So in front view you will get true shape. So simply make this cutting line parallel to XY line and transfer these 4 points of the section, that is point U, point V, PD and PE. Transfer these points on a horizontal cutting line using compass. Directly take this distance in compass and transfer those points here. So this is how you will get all these 4 points on horizontal cutting line. Now project it in the front view and true shape of the section is complete. Vertical line through PD, horizontal line through PD, and this is how you will able to locate PD. Similarly, vertical line through U and horizontal line through U, and you will able to locate U in the front view. So this is how you transfer all the points in the front view, and this is true shape of the section. This is final drawing for example number Thank you for watching this video. I'll see you in my next video. Thank you.